Good afternoon. This is Akanksha Shukla from Information Technology Department, and my today's topic is Principal Component Analysis and the Neural Networks of Data Analytics. So first of all, what are principal component analysis? What is principal component analysis, and how does it works in the neural network? So first of all, the principal component analysis is a kind of unsupervised learning. It is a kind of unsupervised learning which is basically used to reduce the dimensions of particular input data sets. And when we combine these two terms, PCA and neural network, then what we see that artificial neural networks with principal component analysis, it is developed as the second group of the models of the AI, and this is a method which converts the set of variables into the new linear combinations called the principal components. Means, what are the principal components? Basically, the principal components are the variables, are the new variables which we generate or which we generate as a linear combinations or as a matrix variables from the input components. Means, whatever the input data sets we are having, as per input data sets, we convert on the basis of that particular input data sets a new linear combinations, okay, and that new linear combination will contains as much possible as the same information that the particular initial information contains. Means, it reduces the dimensions of the images of the data sets, but it tries to put the data originally, or it tries to put the data as it is only. Okay, it only reduces the dimension, not the information. Now, this PCA, it is a technique. I had already told that it is a technique which reduces the dimensions of the data sets, exploiting the fact that the images in these data sets have something in common. For example, if we take a data sets which consists of photographs of faces, so each photograph will have a facial features just like eyes, nose, mouth, okay, lips. Instead of encoding these information pixel by pixel, we could make a template of each type of these features, and then what we do, then we just combine these templates to generate any face in the data set. Now, in this approach, what we do, suppose in the given example, what we see that in this approach, each template will still be 64 into 64, means 4096 dimensional. But since we will be reusing these templates, basic functions of these templates to generate each face in the data sets. Now, the number of templates required will be small. So, PCA does exactly the same, or we use PCA for doing the same purpose. Means, here what we are doing in the given example, we have a 4096 dimensional template, okay, means we have a template which is having 4096 dimensions, but now we use these templates to generate the each face in the data sets, but now we are going to have the number of templates required. The requirement of the number of templates will be small. So, how can this requirement will be fulfilled? This requirement can be fulfilled by using principal component analysis method. Now, here the data set is a input. Here we can see that. Let's visualize some images from the data set. These are the images which we have taken from the data set. Now, you can see that each image has a complete. You can see that each image has a complete face or facial expressions just like eyes, nose, mouth, teeth, okay, lips. These facial expressions or these facial features can be easily or clearly visible in each of these images. Okay. Now, we have our data sets ready. Now, what we do, we have to reduce the dimensions of these images, or we have to compress that images in spite of having the facial features same. Okay, not means if using PCA, after using PCA, if you gain the data set, whatever the data set you gain, then in that data set also you have to, the facial features just like eyes, nose and lips are easily visible in that particular data set also. using PCA doesn't mean that you are reducing or you are lowering the facial features or lowering the concepts of that particular data set. Okay. Now, for compression or for dimension reduction, there are a 4-step process. Okay. So, starting with the data sets, suppose PCA using PCA, we have a data set which contains the n dimension data requiring the n axis to be represented. So, in the step 1, what we do in the step 1, we standardize the data, means we find a new set of basis functions where some axes contribute to most of the variances which are present in the data sets, while the other contribute very little. Means here what we identify, we identify the standardized functions which are contributing to the most to the variances, or which are contributing less to the variances in that particular data set. Now, in step 2, what we do, we arrange these axes in the decreasing order of variance contribution. Means what we do, we arrange that particular axes in decreasing order of variance contribution. Means which are contributing high will place first, which are contributing low will place second, and which are contributing then low, means less than that particular second one, that will be placed in the next position. Means what we do, suppose we have a 10-dimensional data set and we have using PC, principal what does the task of PC? PC will identify the linear combinations of that particular input variables. So, if you have a 10 data sets, then we have a 10 PCs, but using PCA, we can reduce that particular value by having the maximum contribution values in the first column, and the maximum remaining information contributes to the second principal component, and the third remaining information will be placed in the third principal component. So, in this way, we can arrange the axes in the decreasing order of the variance contribution. Now, in the step 3, what we do, we pick the top k axis to be used. We put the top k axis out of that particular m axis. We pick the top k axis which can be used, and we drop the remaining n k axis. Okay. Now, in step 4, what we do, now we project the data set onto these k axis which we have picked as a top one. After these 4 steps, the data set will be compressed from n dimension to just k dimension. Here, the dimension of the data set which is compressed from the original one having k dimension must be less than the data set having the original dimensions, just like n. Now, here after compression, what we see here, we can, in the given example which we had taken initially, the templates are 4096, which I had told in the starting of that particular topic. So, in the example which I had taken, so here 13,233 images are particularly in the original data set, and 4096 are the dimensions in the original data sets. Now, 577 are the dimensions for the compressed data set, means the data set which is compressed from the 4096 dimensions, it contains only the 577 dimension. So, the formula for identifying the compressed image is equal to the original image into the projection matrix. So, how can we calculate the compressed image or these things? So, here total images are in the original data sets. How many images are there? 13233. Compressed templates are the dimensions of the compressed images 577. Original images 13,233 are the total images in the original data set, and these are the dimensions of the original data set. And the projected matrix contains from where we have projected the compressed data from the 4096 dimensions. So, that will be multiplied to the compressed value 577. So, here we can see these are this is the original image and this is the reconstructed image from that particular example. This is one of the image which I had taken from that particular original data set which contains the 13,233 images. Okay. So here we can see that this is the original image and this is a reconstructed image, or this is a compressed image, and this image has a 4096 dimensions and this is having the 576. But still this contains all the facial features just like nose, eye, lips. So without hindering any information of that particular original data set, PCA does the reduction in the dimensions of the information or of the original data set. Okay, so what I said earlier, that the reconstructed images have captured most of the relevant informations about the faces, and the unnecessary details, means noise data or the missing values from the original data sets are being ignored in that particular reconstructed image. So this is one of the added advantage of data compression, that it allows us to filter the unnecessary details. Even noise which is present in the original data set can also be removed using the data compression methods or using the principal component analysis. Okay. Now I am going to discuss one of the most important topic. This is a fuzzy logic. Fuzzy words means the things which are not clear or which are vague or which are uncertain. So fuzzy logic basically is used to identify the uncertainty in the particular data or in a particular problems, real world problems. So sometimes what happens, we cannot decide in the real life that if the given problem or statement is either true or false. So at that time what we do, this concept of fuzzy logic provides many values between these two values, true and false. So using the fuzzy concept or using the fuzzy logic, we can provide the solution for a particular problem in a more flexible manner, and the best solution of that particular problem can be found using the fuzzy logic. Okay. Now here I am going to discuss about one of the example of the fuzzy logic in comparing whenever we are comparing it to Boolean logic. So here, is it hot water? So the two options are yes or no. Okay. So using Boolean logic, you can provide only the two solution, yes or no, means 0 or 1, true or false, yes or no. But if we move on to the fuzzy logic, then what we see, that if you have a problem that is it hot water, then you can have a flexible way of answering that particular question, that very much, little, very less, means you have more options to reply or to solve that particular problem or to answer that particular problem with the use of fuzzy logic. Now basically, the fuzzy logic contains the multiple logical values, and these values are the truth values of a variable or a problem between 0 and 1. Not 0 and 1, fuzzy logic contains the multiple logical values which comes under the 0 or 1. So this concept was introduced by Lofty Zedhe in 1965, and this is based on the fuzzy set theory. This concept provides the flexibilities or provides the possibilities which are not be able to provide by the computers, or which are not even given by the computers, but similar to the range of possibilities generated by the humans. But this concept provides the possibilities which are similar to the range of possibilities which can be generated by the human beings. So what we see in the previous example, that in the Boolean logic we have only two way to solve the particular problem or to answer the particular problem, that is 0 and 1, means only two possibilities are there in the Boolean system, only 0 and 1, where 1 denotes the absolute truth value and 0 denotes the absolute false value. But in the fuzzy system, what happens in the fuzzy system, there are multiple possibilities present between, which can be present between 0 or 1, means partially false and partially true. These values can also be represented with the use of fuzzy system. The fuzzy logic can be implemented in the system just like microcontrollers, workstation based or large network based systems for the achieving the definite output, means if you have to declare or if you have to find out the definite output for a particular problem in spite of true or false, then in that particular cases you have to implement the fuzzy logics. For example, I want to give one example here, Just like for if you are driving a car, okay, so speed of a car varies from 0 to 40, then 40 to 80. Okay, so if you have to find, or if you have to answer the question that whether the speed of a car is fast or slow, then using Boolean logic, you have two solutions, either fast or slow. But how much fast you are speeding a car, how much slow you are speeding a car, that cannot be answered using a Boolean logic. So that answer can be solved, or that answer can be get by using the fuzzy logic. And it can also be implemented in both the hardware or softwares. Okay. So means the one of the most basic advantage of using the fuzzy logic is that in fuzzy logic there are more, or there are many possibilities for representing the solution of any particular real world problems. Okay. Now, what are the characteristics of the fuzzy logic? First characteristic is this one is a flexible manner, and we can also easily implement it, and we can also easily understand that particular concept. Second one is it is used for helping the minimization of the logics which are created by the humans. The third one is it is the best method which we use for finding the solution of those problems which are suitable for approximate or uncertain reasoning. Means for uncertainty, the fuzzy logic is the best method which for those problems which are uncertain or which contains the uncertainty. It also offers two values which denotes the two possible solutions for a problem and the statement. It always offers two values which denote the two possible solutions for a problem and a statement. Means here we have two values. Okay, means two possible solutions for any problem can be provided by the fuzzy logic. Next one is it allows the users to build or create the functions which are non-linear of arbitrary complexity. Means it can also be capable, or it can also be able to allow the user to create the functions which are non-linear. Okay. Fuzzy logic, everything is a matter of degree. Means it is in this way, just like in the previous example, using Boolean logic, we only give two possibilities, that whether the speed of a car is fast or speed of a car is slow. But you cannot identify the degree of fastness and the degree of slowness of that particular speed of a car. So that particular solution can be provided by using the fuzzy logic. Okay. Means in the fuzzy logic, everything is a matter of degree. Here you can identify the degree of things. Okay. Means in the fuzzy logic, there is a membership function. Okay. Based on this, I will discuss in earlier slides, in my next slide, that what are these terms, membership functions, or how can we identify these degree of fastness or slowness of particular speed of a car. Okay. In the fuzzy logic, any system which is logical can be easily fuzzified. Okay. Means the model which is logical, then we can easily you can easily identify, or you can easily provide the solution for that particular system. It is based on natural language processing. Fuzzy logic is based on the natural language processing, and it is also used by the quantitative analyst. Means if a particular algorithm executions is not performing as per desired output or as per desired requirements, then that fuzzy logic can also be used for that particular quantitative analysis. Okay, to enhance or to improve that particular algorithm execution. Okay. It also allows the users to integrate with the programming also. Okay. Means you can also use the fuzzy logic means you can integrate that fuzzy logic concept with the programming concepts also. So these are some characteristics of the fuzzy logic, that this is a flexible. The concept of fuzzy logic is flexible. It minimizes the logics which are created by the human. It is one of the best method which can be used to solve the problems which are uncertain, and it always offers the two possible solutions for a problem. And everything in the fuzzy logic, everything is a matter of a degree. You can identify the degree of work or degree of a task of anything inside the fuzzy logic, whereas in the Boolean logic we have only two possibilities. Here multiple possibilities for a particular solution, for a particular problem can have. Okay, and it is based on the natural language processing and also used by the quantitative analyst for improving or for enhancing the algorithm execution, and also it uses or it allows the users to integrate with the programming concepts. Okay, so that's all for today's lecture. In my next lecture, I will continue with the fuzzy logic concept. That's all. Thank you.